So now we will see the next set of questions of our dental materials. Now here they were asked, the picture represents which defect in acrylic dentures. In the first picture, they've shown us some porosities or roughness over the denture. Now let us see what are the options here. First option is grazing. Second is improper mix of polymer and monomer. Third is gaseous porosity. And fourth is rough surface. Now the answer to this is gaseous porosity. Now why does gaseous porosity occur in our denture is the boiling point of monomer is 100.3 degrees Celsius, and if the temperature of the dough is raised significantly above this, the monomer will boil, producing spherical voids in the hottest part of the curing dough, which becomes in the maxillary denture the palatal portion. Okay, and these will be apparent as gaseous porosity in the cured denture basis. So we'll have in the maxillary portion, the palatal portion shows most commonly these gaseous porosities, and in mandible we'll see in the retromolar area these gaseous porosity because the thickness of denture is more there. Now the picture shows use of dash in conjunction with zinc oxide, zinc phosphate cement as base. Now the first picture they placed amalgam, zinc phosphate cement lining, and beneath zinc phosphate, okay, they've placed another lining. Is it a lining of calcium hydroxide or GIC or varnish or composite? See, composite and GIC have to be ruled out. Okay, if you're using GIC, it will be directly used as a base. Okay, so we are left with varnish and calcium hydroxide. The answer to this becomes calcium hydroxide. Okay, because this is a place of deep fillings. Okay, now the deep fillings, the consistency of zinc phosphate makes them difficult to apply to cavities in thick section. Okay, therefore there is a commonly used technique that is of thin sublining of a calcium hydroxide cement and to build up a base of a cavity with zinc phosphate material prior to amalgam condensation. Okay. Now the diagram represents which property of a material. Now here we have applied force to burnish it. Okay, but again the metal or the crown has come back to its original form. Now ductility is into rolling or wiring. Okay, malleability is into sheets. Now, elastic modulus is recovery or within elastic limits recovery of a material. Flexibility is bending of the material. Now the answer to this elastic modulus, okay, or elastic recovery. Now the principle of elastic recovery is illustrated in the figure, okay, for a burnishing procedure of an open metal margin where a dental abrasive stone is shown rotating against the metal margin to close the marginal gap as a result of elastic plus plastic strain. However, after the force is removed, the margin spring backs to an amount equal to the total elastic strain. Okay, so here when we are trying to apply any load over in this property against the crown, okay, you can see it is trying to come back out again. Okay, now this total closure can only be made if you're trying to remove the crown, okay, take a fresh impression and burnish it over a cast. Okay, because you have an equal amount of elastic strain also coming from the tooth, okay, which causes this property of elastic modulus to revert back of your crown. Now the water powder ratio of alginate is 36 ml of water to 20 gram of water, 36 ml of water to 18 gram of water, 38 ml of water to 20 gram of water, 38 ml of water to 18 gram of water. Now the correct answer is 38 ml of water to 18 gram of water. That is the recommended water powder ratio for our alginate, what we constantly use. But in our clinical practice, what they give is a measuring jar for the water and a scoop for your powder, which are approximately around 38 ml of water to your 18 grams of powder. Now, what is the polymerization shrinkage if 3 is to 1 pre-polymerized polymer to monomer ratio is used? Is it 10%? Is it 7%? Is it 15%? Is it 21%? Now the answer to this is 7% because in pre-polymerized polymer they have asked us pre-polymerized polymer. What happens in pre-polymerized polymer is already there is some amount of polymerization happened. Okay, if we are using non pre-polymerized polymer, okay, the shrinkage will be more because the polymer powder will polymerize and shrink more. But in pre-polymerized, as already they are pre-polymerized, there is some polymerization already happened. The resultant shrinkage will be less, which is about 2/3 less than the normal polymerization shrinkage. So of 21%, it becomes 2/3 less. That is up to 7% of your polymerization shrinkage is seen in 3:1 prepolymerized polymer to monomer ratio. Now temperature for brazing. Okay. Now is it 200 degrees? Is it 250 to 350 degrees? Is it 350 to 450 degrees? Or is it less than 450 degrees? Now for soldering, we use a temperature of less than 450 degrees with a pair with a third metal, okay, filler metal with in conjunction with two parent metal. But in brazing, we heat it above 450 degrees Celsius, okay, in conjunction to the parent metal itself only. You're not using a filler metal, but you'll use only directly the parent metal and heat it above 450 degrees Celsius. The indenter in the picture is of which test? Brenell, Rockwell, Wicker, or no? Now Brenell has a ball-shaped stainless steel ball. Okay. Now Rockwell has a ball like your Brenell or a conical diamond point. Okay, Vickers has a diamond point and Noakes also has a rhomboidal point. Now this is a conical diamond point which we can see in the picture here. Okay, which is for our Rockwell test. Okay, in this, instead of measuring the diameter of the impression, the depth of the penetration is measured by a dial gauge on the instrument. Now the picture represents which type of polymer chain. Okay, now here with the linear, we can also see branching of the polymer chain. So the answer has to be a branched polymer. Okay, your cross-linked is the branched and the linear polymer. Okay, having interlinked. Okay, if they are joined, then it becomes a cross-linked polymer. Now the machine in the picture is used for which impression material and how much is the ratio of base and catalyst paste used? Now, is it for addition silicone? Is it for polyether? Now, we have got first is exclusion. Now, this is a Pentamix machine, what we can see in the picture here. Okay, and it is used in our polyether impression material. Now, for the ratio, so we have to exclude addition silicone option. Now, we're left with polyether option, that is B and C. Now, this in this machine, you require a ratio of 5:1. It's in the name, that is penta, that is 5. In the Greek word, it means 5, reflecting the mix ratio of base to catalyst paste of about 5:1. Now, air abrasion uses 27 microns alumina, 40 microns alumina, 100 microns alumina, or none of the above. Now, the commonly used aluminum particles, okay, air abrasion or microabrasion technology is method of removing decay with tiny particles of aluminum oxide or silica. Now, commonly what we use is 27 micron alumina, but yes, when you're trying to remove a cement or something from the crown portion, you can also use 40 alumina particles. Now, type II ZOE impression paste has a setting time of 8 minutes, 10 minutes, 12 minutes, or 15 minutes. Now, they are asking is type II. There are two types, that is type 1 and type 2. Type 1 is hard setting, hard variety of zinc oxygenol impression paste, and type 2 is soft variant of zinc oxygenol impression paste. So, as per the textbook, type 1 has 10 minutes of setting time and type 2 has 15 minutes of setting time. Now, they have asked us about type 2, which is around 15 minutes of setting time. Now the picture represents which type of porosity. Is it localized shrinkage porosity? Is it subsurface porosity? Is it suckback porosity, or is it pinhole porosity? Now we have to see the sprue design here. Okay, it is a narrow sprue design which we can see in the picture for both the casting effects. Okay, now when you have improper sprue design, it causes, okay, the sprue design is not exact, it causes suckback porosity. So what happens is the metal entering metal impinges on the mold surface here, and it creates a higher localized mold temperature near the sprue end. Okay, improper bend of the sprue, which causes suckback porosity, wherein the metal goes back, which is not flowing into the mold cavity. That's why it is called as suckback porosity. Lithium disilicate containing crystals in ceramic crown are IPS Empress, Cerastor, IPS Empress 2, or Dicor. Now, Cerastor is your shrink-free ceramic, okay, and Dicor is your machinable glass ceramic. So definitely they are not your lithium disilicate ceramics. Now, in IPS Empress and IPS Empress 2, both are glass ceramics, and lithium disilicate is also a variant of glass ceramic. Okay. Now, but in your IPS Empress 1, you have your silica based, not your lithium based glass ceramic. Okay, but and in your IPS Empress 2, they modified with addition of lithium. So it is lithium disilicate. For this, his answer is IPS Empress 2. Now the best tissue tolerated material for our crown and bridge, okay, highly polished porcelain, highly polished metal, highly glazed porcelain or highly polished acrylic. Now by the exclusion method, acrylic has to be removed first as an option which cannot be chosen. Okay, again metal also can be removed, okay, because it will not can't be polished as high as your porcelain. Now in polished porcelain or glazed porcelain, what is most recommended is glazed porcelain, because glazed porcelain also closes the porosities which are present over the ceramic after firing, and also these porosities, once they are gone, that also prevents leaching of the material into ceramics, and also it prevents plaque accumulation, maintaining your tissue health. pH of wet cement remains below 7 even after 1 month of placement into oral cavity. Like, is it zinc phosphate, is it zinc eugenol, is it resin cement, or it's silicate cement? Now the answer to this is your silicate cement, whereas all other cements almost have less, okay, less than more than 7 after 1 month. Okay, more than 7 after 1 month for all other cements happens. Okay, they become more alkaline. Custom trays are important part of rubber-based impression techniques since elastomers are more accurate in uniform thin layers of 0.5 to 1 mm thick, more accurate in uniform thin layers of 1 to 1.5 mm thick, more accurate in uniform thin layers of 2 to 4 mm thick, more accurate in uniform thin layers of 5 to 6 mm thick. Now, when we're talking about rubber-based impression, if you're fabricating, you're taking impression for rubber-based, that is your regular body or heavy body impression material, then you definitely require a custom tray. Okay, if you're using a putty or a light body, you can go around with stock trays. But when you're trying to use a heavy body or a regular body impression material of elastomer, then we definitely require a custom tray. Okay, and that too, a minimum thin layer of 2 to 4 mm is required for adequate dimensional stability, okay, and tear resistance for your material. Okay, now the accuracy and reliability of an elastic impression is controlled by the tray in which it is taken. Now the best tray is one that is custom made for each patient. Okay, high fusing porcelain is usually used in the manufacturing of, is it denture teeth, all ceramic crown, metal ceramic crown, or all of the above. Now your high fusing ceramics, okay, they have very high strength and they're used only in your denture teeth fabrication. Now, high fusing ceramics have a temperature of around 1288 to 1370 degrees Celsius, which is used for denture ceramic. Medium fusing around 1090 to 1260 degrees Celsius, which is used for all ceramic and porcelain jacket crowns. And low fusing, which is 870 to 1000 degrees Celsius, which is used for your metal ceramic crowns. Teeth that appear to be color matched under one type of light may appear very different under another light source. Now, this phenomenon is called, this is a classic definition of our metamerism. Okay, so the answer has to be metamerism. Now, why it is important is even when you're trying to check the shade of the tooth, it is always advisable to check the shade of the tooth under two different light sources. Okay, one is your normal light source available in your dental office, and the other is your natural light. Okay, and also they have to make a note that staining of the porcelain will increase the metameric responses. In mixing dental stone, why should the powder be sprinkled onto the water in the ball? Now, what happens with this sprinkling of powder into the ball? Is it addition of powder prevents the mix from becoming exothermic? No, this is not recommended. The water should be added to the powder. No, definitely the water has to be taken first and then only the powder has to be added, which is a saturation technique what we are following here. Okay, this process results in better powder mixing and reduced chance of air bubbles. Powder is added to the water to avoid using more than one bowl. No, it what happens is when you're trying to sprinkle powder over the water, okay, we see an even diffusion or mixing of or wetting of the powder particles, which also reduces the chances of air bubbles. Now in the picture, white region shows which zone of flame. Now in the first picture, they were asking us about the white zone. There are four zones of flame, that is cold mixing zone or the unburned gases. Okay, then we have partial combustion zone, then we have reducing zone, and then we have oxidizing zone. So the answer to this is cold mixing zone, which is of unburned gases. Okay, now we have partial combustion zone where only gases are trying to enhance into heat. Reducing is the zone where our alloys try to melt. Okay, that is the zone which reduces or melts the alloy. Okay, oxidizing zone will try to oxidize the alloy, not melt the alloy. Okay.